Hello student and teachers, this is the topic in this video, a ballistic pendulum that can be used to estimate the speed of bullet fired from a gun. We start by design of the tool. The main materials are PVC pipes and it is supporting components like T-joints and knee. This material can be obtained from supermarket around us, and it is safe for student or teacher to design this tool. Insert the pipe in T-joints as a base of the tool. We use 4 pipes. The next step is to fix the base on the board by using screws. We first use a double tip to adjust the position of the base. After that, we use a drill and then put the screw to fix the position of the bases. We drill the bases to put the screw. Now we design the stand for the gun. Then we also drill to put the screw. Now we use toy gun to produce a bullet. And then fix at the stand. And then use O-ring to tighten the position of the gun. Now we check the function of the gun by fire testing. Okay, it is function normally. Now the next step is to make a pendulum. We make a hole at the center of the upper pipe to insert the string. And we use sponge as the target. This sponge will be hit by the bullet, and then it moves with the bullet together until the maximum position. And we also insert the stride needle at the front of the bullet, so when it hit the sponge, it remain stick on the sponge and move together. This is a needle, and we try again to fire the bullet. Now we are ready to do experiment. We first put a ruler as a reference to determine the position of the sponge target. We need to understand the initial position of the target and the maximum position of the target after hit by the bullet. The difference in the position determine the speed of the bullet and the target, and from the speed, using the conservation of momentum rule, we can calculate the speed of the bullet. This is the principle of the ballistic pendulum. Now, for safety, we put a block in the back part of the equipment, so when the bullet misses to hit the target, it will be stopped by the barrier. Now let us do experiment, and you see that there is a camera in the front to record the motion of the bullet and the target. Now let us play the camera and see close up the motion of the bullet and the sponge. Now let's us measure the weight of the bullet and the target, because it is important to calculate the speed of the bullet. We use a cheap digital scale bought from the marketplace. Less figure is 0.01 grams. Mass of the bullet 1.08 gram. And we then measure the mass of the target sponge. And we get 4.78 gram, the mass of the ml, mass of the loot or target. Next is determining the position of the before collision and at the maximum displacement after collision. We use a CapCut application to see the frame. So the initial frame when the at the initial position of the target can be seen easily, and we enlarge the view, the screen, and then we capture the screen. And second, we share the position, the maximum displacement of the target and the bullet. Adjust the position to obtain the frame that's showing the maximum displacement, and we also capture the screen, and then we move to the gallery and open the image screen after screenshot and let's to see the scale in the rule easily. Now this is the initial position of the target before hit by the bullet, then we obtain it is H0 equal to 10 inch. And then we open the image of the maximum position of the target and bullet, enlarge to see the scale easily, the ruler scale easily, and we obtain H1 is 11 inch. So the displacement, vertical displacement of the bullet and the target is S1 minus S0. It is equal to 1 inch. All parameters have been obtained. Now we calculate the speed of the bullet. Using the equation you can see from the textbook, how to calculate the speed of the bullet. mb plus ml divided by mb multiplied by square root of 2g delta h. Now we change the unit into meter. 1 inch is the 0.0254 meter, and this gravitational acceleration in Bandung City, where the experiment is conducted, is 9.77 meter per second square. And we put the value 1.08 is the mass of the bullet, 4.78 is the mass of the target, divided by 1.08 and multiplied by square root of 9.77 times 0.0254, and then we obtain the speed of the bullet is 3.82 meter per second. So this is the final result we obtained using this equipment.